चलने देखो गो लाइव कर दे, कोई दिक्कत नहीं। अपने आप नहीं होता ये। Hello guys, welcome to today's live session. Okay, today we are here to talk about crystallography and mineralogy. Okay, so basically I will be covering the basics of crystallography. So what I will be doing, I will be taking I think 2 to 3 sessions on crystallography. Okay, why? Because the crystallography is the most feared subject, like structural geology and crystallography. So these are the most feared subjects in geology. So I will try my best to explain these, okay, step by step. Okay, when we talk about crystallography, what do we have to study? Let's talk about that. Okay, so basically we are having crystallography and mineralogy. This is the subject. Okay, so this is the name of the subjects which we need to study. So in crystallography, what we cover, that I am going to tell. The first thing is that we talk about some definitions. There are different definitions involved. You need to know about their meanings. Okay, you need to understand them, because sometimes, not sometimes, I have recently seen questions directly getting asked from the definitions. Like if you remember GSI pre-examination, there was a question from the mineral definition. Okay, so there was a question. So definitions we have to study here. Okay, then we will be studying about lattice structures. Okay, we will be talking about different types of lattice structures which exist in nature. So because of that, we are having different kinds of crystals which are growing. Okay, now after this, what we see, all the crystals are not same. Their shapes are getting changed. Why their shape is getting changed? Okay, because they are incorporating some impurities in this. Because of the impurities, their structure is getting changed. So we will be talking about different types of impurities. Okay, so we will be talking about different types of impurities. Based on the impurities present in the lattice structures, there are certain defects which are getting generated. Okay, so next we will talk about defects. Next we will be talking about certain defects. Then after studying these things, we will move towards some of the symmetry operations which we apply here, because here we have to talk about our crystallography, okay, minerals and everything, okay, crystal systems and everything. Okay, so for that we need to know about the symmetry operations which we apply. So we will start with symmetry operation. After studying symmetry operations, the next thing which we are going to start is our crystal properties. Okay, so we will be starting with definitions, then we will study lattice structures, then we will talk about impurities, then defects, symmetry operations, crystal properties. Okay, then after studying all this, we will have gathered enough information that we can talk about the crystal systems. We are having different crystal systems which we need to understand. Okay, so we will be talking about crystal systems and their families. So the main topic here is our crystal. This is the syllabus of crystallography and mineralogy. So this is the pattern I take to teach crystallography and mineralogy. Okay, I start step by step. With time we develop your concepts. Okay, then, and because this is the main thing which we need to study. structural geology, we have to imagine things because everything is in 3D diagram, but we are limited here. We can draw them in 2D. So it becomes difficult for students to grasp the concepts because imagining power, okay, that is required. So here also, in order to understand different types of faces, indices, how we name them, indexes, everything, you have to start imagining things. Okay, I cannot draw them. Okay, I will be showing directly the diagrams, but I will try to draw them also. But here 3D to 2D interpretation should be clear to you guys. Okay, so let's start with the first and the foremost basic definition. Okay, that is your mineral. How do we define mineral? Let's try to analyze its definition. So definition of a mineral, if you go and see the books, the first thing there it is written as it should be naturally occurring. It should be naturally occurring. The next thing written is that it should be a homogeneous solid with a definite but not fixed chemical composition. Okay. Next thing is written as it should be of homogeneous composition bracket but not fixed composition. Like this mineral has been defined. Okay, homogeneous composition. After that we are having it should have a highly ordered atomic arrangement. Sorry. Then next is and it has highly ordered atomic arrangement. Okay, so this is how the definition is written, but you need to understand the meaning of everything clearly, then only we can move forward. Okay, there is that we are having a highly ordered atomic arrangement. Okay, and this the last point here is that they have written usually formed by inorganic processes. So this is the definition which is given in the book. This is how we define mineral. Now if you see in this definition there are different parts. Okay, it should be naturally occurring, it should have homogeneous composition, and it should have highly ordered atomic arrangement, and the last thing it should have formed by organic processes. Sorry. Okay, so here are 4 to 5 components which you need to understand step by step. Okay, so let's start with naturally occurring, then I will talk about homogeneous composition and what do they mean by but not fixed composition, then we will talk about highly ordered arrangement, then inorganic process. So some of these are easy to understand, but they need explanation also. So let's talk about first natural occurring. Means that a mineral should be forming naturally. That is pretty much easy to understand. Okay, that it should be forming naturally, no artificially, not artificially, it should be naturally forming. Okay, so these days what we are doing, we are forming minerals in the laboratory also, so that is your artificial synthesis. Okay, so if it is forming by any other means, it is not forming by the natural processes, then we will not consider it as a mineral. Okay, so natural minerals. Okay, usually what happens? Okay, another thing is that it should be a homogeneous solid. Okay, another thing given is that it should be a homogeneous solid. Now in order to form a mineral, okay, what should happen? In nature we are having elements. Okay, those elements combines to form minerals. Okay, then minerals give rise to the rocks. Okay, so what is happening? Elements combine to form. So we are having different types of elements. Okay, so these elements, we can, in terms of chemistry, we will say that elements, they are combining to form a molecule. Different molecules, they will join together and they will finally give rise to a mineral. So I am going to write it directly to form mineral. We are not going to that much chemistry. Okay, so similarly we can take an example here. If we are having a silica, if it is reacting with oxygen, so we are having two different elements and it is giving rise to silicon dioxide. Okay, so what is the name of this mineral? It is a quartz. Okay, so quartz is getting formed. Okay, so if this process is happening naturally in the nature, we will classify it as a mineral. Okay, now after the formation of the quartz, here if you see, in quartz only two elements were required. Okay, now if you take an example of another mineral like your K feldspar, elbite, anorthite, okay, there are different number of elements are required to form. Okay, so for mineral composition is also important. Okay, so here how many elements are required? Two elements, silicon and oxygen. And let's talk about K feldspar. What is the formula of K feldspar? K feldspar is KAlSi3O6. So how many elements are required for the formation of K feldspar? 1, 2, 3, 4. Okay, so here 4 elements are required. So from here we can generalize one thing, that the elemental makeup of every mineral is different. Okay, so they are different from each other. Okay, now let's talk about homogeneous. Okay, so homogeneous composition, by homogeneous composition we mean to say that its composition is same throughout. Okay, that composition is same throughout. Okay, now by homogeneous solid we mean to say that this composition is same throughout. Like if we take an example of quartz, okay, if we taking an example of quartz, okay, let's collect a sample of quartz from anywhere from the world, you will find that its composition is always SiO2. Okay, it is not going to change. So we will say that it is of the homogeneous composition, and this thing, when their composition is same throughout, we call it as a chemical homogeneity. This is known as chemical homogeneity. Okay, this is known as chemical homogeneity. Okay, so this if in the definition it is written as only homogeneous solid, then it is very easy to understand. But if we come back to our definition, see here they have in bracket written but not fixed composition. Okay, they have written but not fixed composition. Its meaning we need to understand. Okay, what do they mean by this one? Okay, one side they are saying its composition should be same throughout, but they are saying that it is not necessary that its composition should be same fixed. Sorry. So let's try to understand what do they mean by definite but not fixed chemical composition. Definite but not fixed chemical composition. Okay, let's try to understand this thing now. For this, I have given you an example of quartz. Its chemical composition is SiO2. It can never change. Okay, so let's try to understand this with the help of examples. Okay, now if we talk about elbite, what is the formula of elbite? Formula, it is sodic rich, okay, NaAl Si3O8. This is the formula for albite. And now these are the fixed compositions. Okay, if an element is going to have this composition, then only we will term it as a albite, and if it has SiO2, then we will term it as a quartz. So they are having fixed composition, but all the minerals, they do not need to have fixed chemical composition, and this question was present in this year GSI pre-examination. They had written 4 properties to define how do we define a mineral. Okay, now there the answer was not fixed composition. Okay, so how do we can say? So let's take an example of olivine. Okay, I am going to explain now how we are saying that they should not be having fixed composition. So I will try to explain that with the help of olivine. Okay, now if you see olivine, how do we write its formula? That its formula is simple. Okay, we write Mg Fe SiO4. This is how we are writing it. Mg Fe2 SiO4. Okay, 2 nahi likha hai. Mg Fe2 SiO4. Okay, now if we go to the field, okay, let's say we are finding, now olivines have 2 varieties. Let's see 2 varieties also. It can be Mg2 SiO4 or it can be Fe2 SiO4. Okay, it can have these 2 variations. Okay, now this Mg2 SiO4 is known as forsterite olivine. The name is forsterite olivine, and this one is phyalite olivine. This is phyalite olivine. Okay, now if we are getting a rock, okay, suppose, so the structure is like this. Okay, this, let's move with the structure. Mg Fe2 SiO4. Okay, this structure I can represent like this: 1 2 3 4, 4 oxygens. Then I am having 1 silica. Then I am having 2 species here. Okay, I am having 2 species here. Okay, so similarly I can prepare 3 variations here. Here it will be silica, oxygen, 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 oxygen. So this portion is going to stay same. So in some places what we are going to find here, Fe and Mg is present, and at some places we will see both the species are taken by Fe, Mg, and both the species are taken by Fe and Fe. So these variations can be seen in the nature. Okay, this is showing that it is not having a fixed composition. Suppose we have taken a sample from one place, let's say one place, and it is having, now it is having more Mg than Fe. Okay, so here we are having 2 places, so maybe it is having more Mg than Fe, but we are taking another sample from any different location. There it is having more Fe character than the Mg, so the composition is varying now. Okay, that is the main point. So the composition is going to vary here. Okay, so there are some minerals which do not have fixed composition. Their composition varies between a range. Okay, so this is what we mean by definite but not fixed composition. So I have explained it with the help of a olivine, but if you take some monomineralic rock, okay, like dunite is a monomineralic rock that is having a fixed composition. Okay, so here what is happening, Mg is to Fe ratio is changing depending upon from the magma from where it is crystallizing, it will vary. So this is what we mean from definite but not fixed composition. Now let's go back to our definition. Now not definition. So next point is that it should have highly ordered arrangement. Next point is that it should have highly ordered arrangement. What do they mean by highly ordered arrangement? Okay. Pen. Sorry guys, there was a power failure. Sorry guys, there was a power failure. So let's see what we were talking about. So we were talking about, okay, We were at the 6th slide. Okay, I think we were going to talk about highly ordered atomic arrangement. Okay, so highly ordered atomic arrangement. By highly ordered atomic arrangement, they mean to say that the crystals, suppose we are having a like this, crystals are arranged like this. Now the distance between them, distance between the motifs should always follow a definite pattern. Okay, so distance between atom must be following a definite pattern. Okay, then only we will say that it is a highly ordered atomic arrangement. Okay, so what should happen here? The distance between the atoms must follow a definite pattern. By definite pattern, I mean to say that if this distance is x, so every time x distance should be x. But many different things happens that we will learn with in coming classes. Okay, so this is what we mean by highly ordered atomic arrangement. Let's go back to our definition. Now the next part is that, last part is that it should be formed inorganically. Okay, so it should not be formed organically. Okay, by inorganically means that it should not have formed by organic processes. Okay, so it should not have formed by organic processes. Okay, now organic processes, or in organic processes, organic molecules are involved. There are 6 elements. Okay, so in organic molecules we are having 6 common elements. They combines to form organic molecules. Okay, you guys might have heard about your carbohydrates, lipids and all those things. So they are having 6 common molecules. Usually we have carbon, nitrogen, phosphorus, oxygen, then your sulfur and hydrogen. Okay, these are the 6 common elements which make up organic molecules. Okay, now in nature we are having a different types of minerals. Okay, sometimes we will see that there is a separate entity which is getting formed. It is also having same chemical composition. Okay, but we will not be considering it as a mineral. Let's take an example. Let's say we are having an example of CaCO3. Okay, calcium carbonate. Okay, now it is getting formed inorganically as well as organically. Okay, it is getting formed inorganically as well as organically. When it is getting formed inorganically, then we will call it as a mineral. But when it is not getting formed as organically, inorganically, we will not term it as a inorganically. Okay, how it is forming inorganically? Do you guys remember, everyone? It is getting formed in marine organisms. Okay, so what is happening? Marine organisms, they are secreting some materials, so they are giving rise to your calcitic shells. Okay, like in your brachiopods, gastropods. Okay, so calcium carbonate is getting secreted and it is forming their shells. So in those scenarios we are not going to consider this as a mineral. Okay, so we should be having a clear cut difference between the inorganics. No living activity or living molecule, organic molecule should be involved in the formation of the mineral. Okay, so this is what we have studied about the definition of the mineral. So I think everyone has gotten the meaning of the every aspect of the definition of a mineral. Okay, now here I have talked about a specific thing, that it should be having a highly ordered structure. Okay, now what will happen when minerals are not having a highly ordered structure? Okay, so we are having a this kind of a structure when it is following a definite pattern. Let's say this distance between different atoms is x, so it is following a definite pattern, but objects have no definite. So we are having a different types of objects in natures which do not have definite arrangement of atoms. Sorry, arrangement of atoms. We call these elements as amorphous objects. These are known as amorphous objects. Okay, so there are two types of objects. We are having a crystalline objects or amorphous objects. So crystalline objects are those which are having highly ordered arrangement. Okay, so basically your minerals. Okay, so crystalline objects will be having a highly ordered objects, then we will be having amorphous objects. They do not have any ordered arrangement. Okay, so if you see, so here I have told you about two things, amorphous objects, and this one is your crystalline objects. I will give you an example now. Crystalline objects. Okay, so if you see, take an example of SiO2. Okay, we are taking not SiO2. Let's talk about quartz and opal. Okay, if we see their composition, both of them are made up of SiO2 only. Okay, quartz composition is also SiO2 and opal's composition is also SiO2, but quartz is considered as mineral. Okay, quartz is considered as mineral, but this opal is not considered as mineral. Okay, why? Because both of them are having different types of arrangement in them. Okay, so here in quartz, what we are having, our elements are arranged in a particular definite pattern, but here opal, they are not arranged in a pattern, so it is a amorphous object. It is a amorphous object. Okay, so I hope this is clear. So these types of things are known as mineraloid. We also call them as mineraloid. I hope this is clear to everyone. Okay, you guys may have understood this thing clearly. Okay, so I will end our today's live session here. Tomorrow, not tomorrow, I will be taking another live session on Monday. There we will be talking about types of crystallines and various types of defects also. Okay, and thanks for watching our video. Please support us. Okay, do like and subscribe our channel. Okay, and those who have further queries about different subjects and everything, they can contact us. Okay, and we here at KP classes, we provide coachings for every subject, every exam, your NET exam, GATE exam, GSI exams. Okay, so everything will be covered here. So those who want to continue and study further, they guys can get in contact with us. Thank you guys.